We have a topic before us today on mathematics called set theory. How do you define set theory in mathematics? Before I go into the definition, I want you to know the importance of set theory in mathematics. Set theory in mathematics is very important that most of our undergraduate students, most of the students that want to write the examination to go into the higher institution, is very important. They have detailed knowledge about set theory. In other words, set theory is very important topic in mathematics. Now, before we go deeper into talking about what set theory is all about, let's define set theory. A set is defined as well-defined collection of data, informations, or any forms of informations that you try to put together to show a particular forms of mathematical expression. In other words, for you to identify set theory, you have to use this symbol to represent your set. This symbol is a symbol that you use in representing the set. That is where all the set information will be enclosed within. Now, in set theory, what the values that will be placed inside this symbol, for instance, if you are asked to give the prime numbers between 4 and 10, prime numbers between 4 and 10, you are going to have it this way. You have it to be 5, 7, I think that is all. That is prime number between 4 and 10, 5 and 7. Now, you can see that this is a symbol that identifies set theory, and this follows all these particular figures you have inside this set theory, or whatever that is placed inside this set symbol, are called elements of a set, and you can also refer to them as members of a set, elements of a set, or members of a set. Element of a set or member of a set. Now, before we now go deeper into the solving of different problems as regards set theory, I want you to take note that before the end of this class, you are going to have knowledge about the type of set that we have, the terms that we use in set, the set notation, and some other important information that are going to be useful for you when you want to have any problem that have to be solved in this form of set theory. At the end of this class, I give you the assurance that you must have gotten detailed knowledge about all this information. Now, before I go deeper into this set theory once again, I want to introduce you to numbers in mathematics, because by the time we start with set theory, all this information will be making use of, and by making use of them, if you have detailed knowledge about them right now, it will be easier for you to know how to place those values there appropriately. Now, in the numbers I'm going to talk about, I'm going to make use of number line. This I call number line. This is 0. The negative value will be here. -1, -2, -3. It goes on like that. This is 1, 2, 3, and it also goes on like that. Now, this arrow shows that this set of values that we have here, these figures, are increasing towards the right hand side. Now, for me to place my numbers, I'm going to start with the natural number. These are called natural numbers. Numbers that are whole numbers, not natural numbers. Natural numbers are whole numbers that start from 1, 2, 3, 4, 5 to infinity, and they are represented by this symbol, capital letter N. It is important for you to know this symbol, because in most cases when you are given a question under set theory, nobody is going to write for you this set is a natural number. They will just make use of these symbols for you to be able to know how to place your appropriate value there. Another set of numbers that we have are from the one again. These are called the positive integers. Positive integers. They can as well be related to natural number because they are the same figure. They start from 1. They are also whole numbers, 2, 3, 4, and like that to infinity. Now, you can see that this is 0 here. If I take this 0 here alongside with all these positive integers, I call it non-negative integers. They are called the non-negative integers. Any number that starts from 0, if you include 0 with the positive integers, they are called the non-negative integers. In other words, the integers are represented by this symbol, capital letter Z. That is the symbol that we use in representing your integers. Now, the numbers that are in the negative part here, from -1, also whole numbers towards this left-hand side like this, are called the negative integers. Negative integers. These are the set of numbers that I'm going to stop here as far as the numbers in this regard are concerned, making use of this number line. I can still talk more and more about numbers, but I'm going to talk about those ones that are important for as far as set theory is concerned. We can still talk about rational number, non-rational number, the so-called and so on and so forth like that. Now, the next one I'm going to be talking about is called the factors of number. Factors of number. The definition of factors of numbers are numbers that can be divided by a number without a remainder. If you are given a particular number and you are asked to find the factor of such a number, the number that you can use to divide such a number without a remainder are the factors of such a number. For instance, if you are asked to find the factor of 4 between 8 to 20, 8 to 20. Now, factors of 4 between the values of 8 to 20, this will be from 8 now. 8 can divide 4 to have a whole number. 8 divided by 4 will give us 2. That is the whole number, 8. What else can divide 4? 9, 10, no. 11, no. 12. 12 can divide 4. What else can divide 4? We have 16. 16 divided by 4 will give us 4. And the one we have again is 20. Those are the values that can divide 4 without remainder. So also if you are asked to find the factors of any other number, for example now if I want to talk about finding the factors of 5 between 5 and 25, you have to look for those values that will divide that 5 without a remainder. That is what is called factors of number. Another number we are going to talk about here is called a perfect square. How do you identify a perfect square? A perfect square are identified by multiplying every number by itself. When you multiply every number by itself, the value it gives to you are called the perfect square. For instance, we have when you have 1 times 1, that will give us 1. 1 is a perfect square. If you have 2 times 2, that will give us 4. If you have 3 times 3, that will give us 9. In other words now, the value that we are able to get here as our answers, they are called the perfect square. In other words now, I can name my perfect square from 1 to 40. Perfect square between 1 to 40 will be, I'll have it here, in this form of set like this, that will be 1, 4, 9, 16, 25, 36. So those are the perfect square between 1 to 40. That is a value we are going to get for perfect square between 1 to 40. Now, another number that I'm going to also talk about are called the prime numbers. Prime numbers. Prime numbers are numbers that can be divided by 1 and itself to give a whole number. If you use any value to divide such a number, the value you get will be in the form of decimal point, decimal values. So in other words, any values that you can divide, that can only divide by 1 and itself, are called prime numbers. Example of prime numbers now. Example of prime numbers, we have 2. Prime numbers start from 2. 2 divided by 1 is 1. 2 divided by 2 is 1. 2 divided by 1 is 2. 2 divided by 2 is 1. 2, we have 3. We have 5. We have 7, 11, 13, 17, and so on and so forth, like that. Those are very good examples of prime numbers. Now, odd number is another number that we also need to talk about when we are talking about the kind of values that we can be asked to bring out their information when we are talking about set theory here. Odd numbers are numbers that are not multiples of 2. As you have it here. Numbers that are not multiples of 2. Numbers that are not multiples of 2, those are the odd numbers. And example of odd numbers can be, odd number start from 1, 3, 5, 7, 9, 11, 13, 15, and so on and so forth, like that. That is the meaning of odd numbers. Odd numbers. Now, the other number I'm also going to talk about here in this class, which I will, from that I can take a break there, is called the even numbers. All of us are familiar with most of these numbers, but we must let them also be part of what we will put in our memory always, so that when we are trying to deal with this set of information as regard set theory, they will be useful and will be able to answer the question appropriately without making any mistake. Now, even numbers are numbers that are multiples of 2. So, example of even numbers, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on and so forth, etc. Now, these are the set of numbers that I think we are going to be making use of those information as far as this class is concerned. I hope you are going to stay tuned, as we are going to be using this set of information to solve some problem as regards set theory, terms that are used in set. Now, this set of terms that I'm going to be making use of right now, or I'm going to be pointing into, are the set of terms that you are going to be getting familiar with, or they are the set of words that you will see the use of them in set theory, and which you have to make use of them by the time you start with solving of the problem. They are very, very important. Now, the first one among the terms of set theory is called the element of a set. The element of a set is given with this symbol. Look at the symbol. This is the symbol of element of a set. Now, this element of a set, what is the meaning? The meaning of this is simply that those values that are inside the given set that are given to you, each of them are element of such a set. Now, for instance, if you have A equal to 3, 5, 7, 9, 12, 15. These are the elements. If I can now say that element of set A are all these here. 3, 5, 7, 9, 12, 15. Those are the elements that are in set A. Now, if I am now asked that is 2 elements of set A, I will say no. Because as you can see here now, you can see that there is no value here that is 2. among the value that we have as a set element of set A here. So 2 is not an element of set A. This is the meaning of that. You can see that I wrote the symbol of the element, then I cancel it. It means that it is not an element of set A. Now, another thing I'm going to talk about here is a number of elements in a set. Now, number of elements in a set. The symbol of such is this. This small letter n is used to identify number of elements in a set. For instance, if I now look at it, let's make use of these values I have here. Number of set A will be equal to, let's count it now. It means all the values that are there, count them one after the other. It might at times, the set that will be given to you or the element of set that will be given to you might not be figures. It might just be some set of animals. It might not just be some set of colors. It might be balls. So you have to count them one after the other. Now, if I want to count the number of elements here, I will say 1, 2, 3, 4, 5, 6. So number of elements of set A here is equal to 6. That is how you identify number of element of set A. Now, or any given set for you. Now, another thing I would like you to take note of is this, and you have to put into your consideration is that this symbol here, this is what is used in defining an element of set that you put in under consideration. You must not make use of this kind of symbol. You make use of this to distinguish your set that are given to you. The set A is equal to all these forms of element like this. Then you make use of this symbol for you to be able to have your mark intact when you are, or for you to be able to express yourself properly, that you understand the topic properly. Now, another thing we also need to know among the so-called types of terms used in set is what we call the subset. Subset is given with this symbol. Subset. As the name implies, sub means within. That is, this is a set within another set. And take note of this, which it is very important for every mathematics student to have at the back of your mind, and it must be what you know. With just an ease, if you're waking up and you are asked such a question, you should be able to provide the answer without thinking about it at all. Is that all sets are subset of one another. Every set are subset of one another. For instance, here now, I have this set of set A here. Set A is a subset of itself. Every set is a subset of itself. Now, if I am given this form of set A, if I am given a set like this, if I have A is equal to 3, 5, 2, 9, 12, 4. This is A, and I am given this set as a x to be equal to 9, 11, 14, 19, and 12. And I'm given this one again, which is a y. I can say that y is a, you can see the symbol must be arranged properly, must be well designed. Y is a 5, 9, 12. Now, this kind of set given to us here now, I can say that y is a subset of A. What do I mean by that? You can see that every element you have in Y here are also available in set A. 5, 9, 12. 5, 9, 12. But what makes Y to be a subset of A is because that there are some other values that are in set A that are not in Y. So Y, all the elements of Y are found within set A, whereas set A still has some elements that are also available, makes it to have more elements more than that of set Y, which means every element here must be A before you can make this a subset of this, and some other elements must available in this other set that is being a subset of as well before you can call a particular element subset of a particular element in that order like that. Y is a subset of it. Let's look at X now. You can see that X has 9 here. There's 9 here as well. 11. There's no 11 here. So in other words, this one is not a subset of this particular value. Y is not a subset of A. Y is not a subset of X set X. Y is not a subset of X, but Y is a subset of A. Now, but you can see that all the elements in A are in Y. So there are some elements that are in set A that are not in Y. So that one will now give us that impression that every element in Y are in A, while some other elements are in Y are in A that are not in Y, makes this A superset of set Y. So A is a superset of set Y. A is a superset. So you now make use of this symbol now of set Y. That is, A is a superset of set Y. That is the meaning of this particular expression. That is, all the element there. So in that sense, we can now say that every element, as we have learned so far here now, is a subset of itself. Every set is a subset of itself. Then, for you to have a subset of another set from a particular set, it means that all the elements in that set must be in the other set is being compared to, and it must as well have all the values, and there are some values that must be in that set that is being subset to that are more than that of the set in question. I think it is clear to every one of us. So we can now move ahead and look at what is meant by number of subset. Number of subset. Number of subset. Now, you can see that I have earlier mentioned what is meant by number of a set. I want you to be clear about this very well. Number of subset is different from number of set. Number of set is the counting of each of the value that are in the element or that are in set given to us. You count each element that are in it, then you give us the figure as a number of set. Now, for number of subset is equal to 2 raised power of n. That is, this is mathematical expression of number of subsets. 2 raised power n, where n is number of sets. Now, mathematically, I can quickly use this in finding the value of my number of subset. I think you've been able to try to imagine what is meant by number of subset, the difference between it and that of number of set itself now. Number of subset is 2 raised power of n. Then, for me to now find the value of, if I am given a particular set of this nature, if set x is equal to 3, 9, 12. Now, you can see that number of this set, what is the number of that x? Number of x, I cannot say number of x is equal to, how many values are there? How many elements do you have there? 1, 2, 3. We have just 3 elements there. So number of that set is 3. Now, the number of subset will be equal to 2 raised power of n, which is equal to 2 raised power of 3 is equal to 8. That is how you can see the difference between the value we get. Number of set is 3, while the number of subset is 8. Now, how do we identify number of subset without making use of this mathematical expression? For instance, the question we have here gives us the values of A, B, C, D sets. Now, A is given as all perfect square less than 30. What is a perfect square? Perfect square is gotten by when a particular number is multiplied by itself. For instance, you can start from 1. 1 times 1 will give us 1. 2 times 2 will give us 4. 3 times 3 give us 9. 4 times 4, 16. When each of those values multiply by itself, the value it gives to us is called a perfect square. Now, A now can now be equal to, it's going to start from 1 because 1 itself is a perfect square. The set of A's are 1, 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, 6 times 6 is 36. And from the question given to us, we are only asked to look for all perfect square less than 30. So we cannot include 36. So the perfect square required, that is that the set of A are 1, 4, 9, 16, and 25. Those are the perfect square that we have in that set given to us. Now, B is given as a set that all odd numbers from 1 to 15. All odd numbers from 1 to 15. Now, what is meant by odd numbers? Odd numbers are those values of numbers or are those integers that are not multiples of 2. Now, you can all divide it by 2. When you divide it by 2, there's going to be a remainder. In that regard, you call such a number an odd number. Examples of them are 1, 3, 5, 7, 9, 11, 13, 14 is not an odd number, and 15 too. 15 is an odd number as well. But the question says from 1 to 15. I think 15 is going to be part of the odd number as well. 15. Because the question says from 1 to 15. So we are going to as well include 15 in such a question. Now, this C part says that C is a set such that C is a prime number between 10 to 35. A prime number between 10 to 35. Now, C could not be, what is the value, what is the meaning of prime number? You can see that we have been able to talk about this when we started the class. Prime numbers are those numbers that can only be divided by 1 and itself. When you make use of any other values, you are going to get a remainder. So those are what we call the prime number, and prime numbers start from 2. Now, but the question is that prime number between 10 to 35. So the next one will be 10 is not the prime number, so the next will be 11, 13, followed by 11, 13, followed by 14 is not. 15 can be divided by 3 to get 5. Can be divided by 5 to get 3. 16 can as well be divided by a value. 17, 19, 20. 20 is not a prime number. 21. 21 divided by 7 will give us 3. So it's not a prime number. 23, next is 23. 23. 24 is not. 25 is not. 26 is not. 27 is not. 9 times 3 is 27. 28 is not. 14 times 2 is 28. 29. Could it be? Yes, 29. 29. But the question says between 1 to 10 to 30. So that is the prime number we are asked to bring out there. Now, for the value of these, D is, they call it factors of 15. When you say a factor of a particular number, factors of a particular numbers are those values that will be divided by such a number that is going to give a whole number without a remainder. Now, what are those values that you can use to divide 15 without a remainder? You can be talking about values like 1. Yes, when you divide 15 by 1, you will get 15 without a remainder. You can talk about 3. You can talk about 5. You can talk about what else can we talk about there? You can talk about 3. You can talk about 5. You can talk about 15 itself. So those are values of the set. Now, the questions that we have there. Now we have been able to bring out the values of these. You can see from the set notation given to us or the expression given to us, they do not mention these values in this order like this. We are only given what they are going to be translated into, and those translations are the ones that give us all these set elements like this. Now, the question now says we should find the value of A intersection B. That's the first question there. A intersection B. As we have heard earlier, that what is the meaning of intersection? Intersection means common values. Now, what is the common value between A and B? What are those values that are common to them? A intersection B now could now be 1 is here, 1 is here. 1, comma. 4 is here, 4 is not here. 9 is here as well. Okay, 9. 16 is here. 16 is not here anyway. 25 here. 25 is not here. Okay, let's check here. 3, no 3 here. 5, no 5 here. 7, no 7 here. 9, 9. Yes, we have it here. 11, no 11 here. 13, no 13 here. 15, no 15 here. Now, we can be able to say that A intersection B is equal to 1, 9. That is the value of A intersection B. Now, for the value of the second question there, the second question says we should find the value of A union B intersection D. In this case, I will advise you, when you want to solve this kind of a question, what you need to do here first is bring out the value of A union B. Now, we can now say that A union B will be the value we are going to have there, all the values that are in A and B. You must make sure that you do not repeat 1 2 times. If 1 is repeated twice, just write it as 1. So look at 1 here, there's 1 here as well, so it's just 1. 1. What's the next value? Let's write it in order of their increment, in ascending order. 1, 3, 4. What else? 5. Do you have 6 there? No 6. Then next is 7. Next is, do you have 8? No 8. We have 9. Next is, we do not have 10. We have 11 there. 11. No 12. No 13 is there. 13. No 14. There's 15. 15. Then 16. All the way up again. We have 25. That is A union B. Now, for the A union B intersection D, we can now look at the value we have here related with D here. Now, A union B intersection D will now be what? 1 is here, 1 is here, 1. 3 is here, 3 is here, 3. There is 5 here. Do you have 5 here? 5 as well. 5. We have 15 here. Do you have 15 here? 15. You can see that it seems that all the elements in D are in A intersection B, A union B intersection D. So you can also just say that what? A union B intersection D is equal to D is equal to element of D. The numbers are the same and the values or the elements within them are the same as well. They are equivalent to one another because all the elements out there are the same. Now, that's the second question we've been able to solve right now. Now, the third question says we should find the value of B intersection D union A intersection B intersection D, I guess, yeah. B intersection D union A intersection C union A intersection C. Now, you need to firstly, or in the first instance, bring out the value of B intersection D, then you bring out this value, then you now form the union of them together. B intersection D now, B intersection D will be equal to, now let's look at it, B intersection D. What are the common values here? 1, there's 3 here, there's 3 here, 3, 5, 5, 5, they have 15 too, that is 15 as well. Then we are going to find the value of A intersection C as well, which the value is, the values are, elements there are A intersection C. A, this is value of A. 1 is here, no 1 here. 4, no 4 here. 9, no 9 here. 16, nothing related to it. 25, no here. 11, no 11. 13, 17, no. 19, no. 23, no. 29, no. So this one is a null set. It is a null set. There is nothing that is common between the two of them. Intersection of the two of them, there's nothing that is common there. Now, in that regard there, when it's a null set, we can now bring the value to be, what is the value of B intersection D, B intersection D, union A intersection C. Now, we have this value as B intersection D, including nothing that is here. So, we're going to write out the value that is here, which is going to be the value of B intersection D. 1, 3, 5, and 15. Don't forget that we are not talking about intersection here. We are talking about union. And there's nothing here. Nothing with something that is available. Bring them together. The available one will show up itself. So, in the other regard now, we can say A. Now, with the fourth one, the fourth question that we have here, that will be, that one says the fourth question says that what is the value of B union D intersection A union C? B union D, the fourth, intersection A union C. B union D intersection A union C. Now, they need to bring out the value of all these out. So I'm going to make use of this part now. Let me divide this into two parts. Now I'm going to bring out my B union D first. B union D will be the value such as B union D. That will be 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. 7, 9, 11, 11, no 12, 13, no 14, 15 is here, that 15 is here as well, 15. So that is B union D. 1, 3, 5, 7, 9. Look at the value there, 1, 3, 5, 7, 9. 11 is here as well, 13, 15. And this one is 1, 3, 5, 15. So I think that is in order. Now, when we have value of A union C will be, what is the value of A union C? A union C, that will be 1, 4, 9. Everything there, you have to write it out. 1, 4, 9, 9, after 9. Then before 16, we have 11, 13. 11, 13, 16, 17, 16, 17, 19, 23, 19, 23, 19, 23, 25, 29, 25 and 29, 25, 29. Let's check it very well. The union of A union C will be 1, 4, 9. Is there? Higher, 11, 13. Then we have up there 16, 17, no 18. Then next is 19, 23, 25, 29. Now, the intersection of the two of them now, according to the question given to us as number 4, which is B union D intersection A union C. A union C will be, now let's have the intersection values here. We have 1 is here, 1 is here. That's 1. Come on. 3 here, there's no 3 here. 5 is here, there's no 5 here. 7 is here, no 7 here as well. 9 is here, there's 9 here. 9, there's another value there. 11 is here, 11 is here. 11, 13 is here, 13 is here. 13, 15 is here, 15 is not here. Those are the values that are common to this intersection of B union D, intersection A union C. Check it very well. You can see we have 1 is here, 1 is here. We have 1 there. 3 is here, 3 is not here. 5 is here, 5 is not here. 7 is here, 7 is not here. 9 is here, 9 is here as well. We have it there. 11 is here, 11 is here. We have it there as well. 13 is here, 13 is here as well. 15 is here, 15 is not here. So the remaining values that are here, definitely they are not also, but they are not the value that are here. So that is the answer to our question given to us. You have to stay tuned. We have the universal set here, which we also have the value of set A, B, C, and D. Now, in that set, we are asked to find the value of some element of set. Now, the first thing we need to do here is to bring out the values of those our set notation given to us. That is the first thing we need to do. You have to bring out those values. When you bring out those values, then you'll be able to know how to do the answer properly. Now, I think I need to divide it like this. Now, our universal set, as we all know, that is represented by this symbol. The universal set represented by that symbol, like that. Now, we can now say that with the universal set like that, this universal set as is given to us here says that X is universal set is set such that X is a member of that capital letter N, means a natural number. And what we all understand what is meant by natural number. Natural numbers are those positive numbers that start from 1 to infinity. Natural number that is less than 25. Now, the value of this universal set will now be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. When I do something like this, I mean you continue in that order and have 20, 21, 22, 23, 24. Don't forget that from the set notation of universal set given to you, it has been stated there that X is such a set that X is less than 25. So you must not write 25 as part of the number, because the question has stated there that it is less than 25. So you have to stop at 24. If the notation is in form of less than or equal to, you can put 25 as well there. But that particular inequality sign says that it is less than 25. You have to state it in order. Now, we have the values of A, B, C, D also given to us from the set notation. Now, you should not take note of one thing. Once you have been given the universal set. All other sets given to you, they are going to place their value under this universal set. That is, they are going to be subset to the universal set. Every set that they are going to form will be within the values of this universal set. And according to what we have here, A is given as the value of what? Even numbers. Even numbers. Here, A is an even number. That is what is given to us. Now, what are the values of even numbers that are between 1 to 24? Even numbers, you know, the even numbers are the values that are multiples of 2. They can be integers, they can be natural numbers that are multiples of 2. So we can now start from 2 itself. 4, 8, 10, 12, 14, 16, 18, 20, 22, 24 itself. Those are the even numbers that we have there. Now, the next value, which is for B, the B set, as we have it there from the set notation there, says that B are perfect squares. Don't forget, I have told you that those values will take their element that must be within the universal set given to us. So now, for the values that are the B element now, don't forget that perfect squares start from 1, because perfect square are values that when you multiply it with one another, they will give you when you multiply a particular value with one another, is going to give you a particular answer. It gives you is going to be the value of your perfect square. So when you multiply 1 by 1, that's the perfect square. That's 1. 2 by 2, the perfect square is 4. 3 by 3, the perfect square is 9. So the perfect squares are 1. 2 times 2, 4. You move on like that. 3 times 3, 9. 4 times 4, 16. 5 times 5 is 25. I think we are not going to include 25 as part of our perfect, because 25 is not among the value of the universal set. And don't forget that I have told you that every all other set except that of universal set will be subset to the universal set. Now the C part of this question says that we should find the value of the numbers divisible by 4. Don't forget, I have told you earlier that those values that will be gotten from A, B, C, D must be a subset to the universal set. So those values of numbers divisible by 4 will be 4 itself, 4, 8, 4, 8, without remainder, 12, 12, 4, 8, 12, what else? 16, 16 divided by 4, then 20, then 24, and the 4 itself. 4, 8, 12, let's check it. 4, 8 divided by 4, 2, 12 divided by 4, that's 3, 16 divided by 4, 3, 4, 5, 6. So it must be in that order, the answer we must get. Now, for the D part. D part asks us to provide the value of the odd numbers. And we all know the meaning of odd numbers. Odd numbers are set of values that they are integers that are not multiples of 2. They start from 1. So odd numbers are 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. It stops there. 1, 3, 5, 7, 9. You can see that all these values, when you multiply any value by 2, they cannot get them. But those values that are in between them, 2, 4, 6, those one can be multiplied by 2. Those one are called the even numbers. They are multiples of 2. But odd numbers are the opposite of the even numbers. They are numbers that are not multiples of 2. Now, we have been able to provide all these values here. They are subset to the universal set, which we have been able to bring out by ourselves as well. Now let's look at how we solve the question properly. The first question says that we should find the value of A union B, A union B, union C, union C. There's complement here. Now, when we have a question of this nature, the first question is this: A union B complement union C. Let's bring out this value out first before we go into solving the question. I will implore you to make our provision for your writing material, as we are going to be bringing out these values, because it is going to require me rubbing off the board often or one after the other like that. Now, so I think the first value I must try to bring out here is B complement. As I've told you earlier, this is a symbol of complement. This is B complement now. Now, what is B complement? They are values that are in universal set, but they are not in that value given to you. Now, you have, what are those values now? B complement will be, there will be 1 is not there, 2, 3, 2, 3, 4 is here, no. Now, the next is 5, 6, 7, 8, 9 is here, no. You have 10, 11, 12, 13, 14, 15, 16 is here. No, that's 15, 17, 18, 19, 20, 21, 22. Separate them by a comma. 22, 23, 24. That is B complement. Now, we need to bring up, we have been able to get the value of our B complement now. Let's now relate it with our A. B complement now. A union B complement now. Let's find the value out. A union B complement. This is A now. Union B complement. I think we are going to write everything out. So you can see that there is no 1 in the 2 of them. Look at it. This A, this is value of A, this is B complement. There's no 1 in the 2 of them, so this will be 2. Start from 2. There's 3 here, 3. There's 4 here, 4. 5 here, 5, 6, 7, 8. Do you have 9 here? We do not have 9 here as well. So 9 is not there. 8, 9 is not there. 10, 11, 10, 11. Then followed by 12. 13, 14, 15. Do you have 16 here? Yeah, 16 is there. Yeah, 16. Do you have 17 there? 17 is there. 17, 18, 19, 20, 21, 22, 23, and 24. That is the value of A union B complement. Now, the real answer we want to find is A union B complement union C. The answer to A union B complement union C. Now, so everything we have here now, union with the value of C here. So which will be equal to, we have 4 here. Do you have 4 here as well? We have 4 here. We have 8 here. We have 8 here. We have 10 here. We don't have 10 here. We have 12 here. 12 here. 16 here. 16 here. 20, 20, 24, 24. I can now tell you categorically that the value we are going to get for A union B complement union C will as well be equal to A union B complement. You can see there. Because A union B complement union C, all the value we have here are also here as well. That's 4 here, 4 here, 8 here, 8 here, 12, 12, 16, 16, 20, 20, 24, 24. So all other values must be included because we are talking about union here. So That is the value that is going to give to everything here will be the value of our A union B complement union C. That is the answer to that question there. Now, the next question says that we should find the value of A intersection B complement. A intersection B complement. We are lucky we've been able to find the value of B complement initially. So I think A intersection B complement is what we need to find now. I think there's a bracket there. Yes, it is inside a bracket. A intersection B complement. Now, as we have the bracket here now, the first thing we need to do here, we are going to neglect the value of B complement now because the two of them, A intersection B, they are in bracket. So the complement is outside the bracket. It is after we have been able to find the value of A intersection B, then we'll now look for those values that are inside the universal set, not in there. Now, A intersection B now, so let's look at the value for that one. A intersection B, this is A intersection B, that will be 4. For what again? Do you have 9 here? No. We also have 16. 4 and 16. 16. That's value of A intersection B. That's the value of A intersection B. 4, 16. 2 is not here. 4 is here. 4 is here. 1 is here. 1 is not here. 9 is here. 9 is not here. 16 here. 16 is here. So it's only 2 values that are common to the 2 sets there. Now, A intersection B, put in bracket, complement outside now. You can see there's a difference between when there's complement outside now. Complement now will be equal to, we are not dealing with what? Universal set. That will be 1, 2, 3, 4 is not going to be there. Because that will be values that are inside the universal set that are not here. So there's a value now. 1, 2, 3, 4 is not there. That will be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, 23, 24. Those are the values of the answer to our question, that is A intersection B, open the bracket and close the bracket, complement. Those values that are inside the universal set but not here. It's only these 2 values that are not there. So definitely we should be able to have, I think, 22 values here because we have the value from 1 to 24 here. So we have 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That is the number of these value of A intersection B, put or close the bracket, complement. Now, the third question says we should find the value of A intersection D, close the bracket, then union C complement. That is the third question. Now, we have to bring the value of A intersection D out first, then we'll now find the value of C complement. So let's look at the value of A intersection D now. A intersection D will be equal to, now let's look at it. This is value of our A, this is value of our B. 2 here, not 2 here. Intersection, don't forget, those are the common values that we are looking for. 4 is not here. 8, no 8 here as well. 10, no 10 here. 12, no 12 here. 14, no 14 here. 16, no 16 here. 18, no 18 here. 20, no 20 here. 22, no here. 24, no here as well. So that is a null set. So I call it, you can just give it this way like this. It's a null set, no element of A intersection D as we have it here. Now, because there's nothing that is common between A and D. Now, for the C complement now will be equal to, those are the values Now let's look at it. C complement, those are the values that are inside the universal set but not in C. I think we are going to have 1, 2, 3. So this is 4 here. We don't need to mention 4 again. We are going to have next what? 5, 6, 7. So 8 is here. No need to mention 8. That's 9, 10, 11, 12 is here. No need to mention 12. That's 13, 14, 15, 16 is here. 17, 18, 19, 20 is here. 21, 22, 23. So those are the values of C complement here. Those values that are inside the universal set but not in these particular C that we have here. Now, after we've been able to get that, for us to now find the value of A intersection D union C complement will be equal to, since the A intersection D is a null set, that will be equal to C complement, the value we have for C complement. That is the value of A intersection D union C complement, because it's going to be everything, including there is nothing. Then the fourth question says we should find the value of B intersection C complement. Fourth question says we should find the value of B intersection C complement. Now let's look at, thank God we have the value of C complement here already. B intersection C complement. We are going to have it to be, this is B, this is our B, the C complement. The first value here is 1 is here, 1 is here. Oh well. 1, come on. 4 is here. Do you have 4 here? No. 9 is here. Do you have 9 here? Yes, 9. You have 9 here too. 16 is the last one here. We do not have 16 here. So the intersection B intersection C complement is 1, 9. That is, the element we have here is 1 and 9. That is how you solve question of this nature. And you can see how easy it is, though a little bit trickish, but all you need to understand is how to be able to bring out all this value from their set notation information given to you. When you are able to bring them out from the set notation given to you, it will be easier for you to solve appropriately. Stay tuned for